Hi math students, and welcome to our lesson on one-step equations. Before we start looking at some equations, the first thing I've got is 3 review questions for you. These should be just like short questions. The first one says negative 4 times 5 equals, well, 4 times 5 equals 20, and a negative times a positive always gives us a negative. The next one says negative 3 plus negative 3. Here, both of those numbers are negative, so we're going to be left with a larger negative number. I want to add and then keep that negative sign. That one you can always think of money if you want. This is like having a debt or owing $3, owing another $3, which means you owe a total of $6. I noticed on the homework that's a lot of what our students are thinking of as money when they're doing these. And then the last one says negative 4 plus 4 equals, well, here they're different signs. I've got a negative and a positive, which means I want to subtract. That's going to leave me with 0. And because it's 0, I don't need to worry about a sign. Again, if you, instead of thinking of the rules, you can think of it with money. This is like having a debt of $4 and having $4. Well, if you pay the $4 you owe with the $4 you have, that's going to leave you with $0. I wanted to start us off by warming up with some problems with negative numbers, just because our questions today are going to have some negative numbers in them. Specifically, today we are looking at equations. Solving equations is going to be a really big concept in pre-algebra and something you are going to do all of the time in an algebra class. So this is really an introduction to solving equations. Specifically, we're going to look at equations that you solve with one step. In your future will be equations that you need more than one step to solve with. So like I said, this is more of an introduction. To get us started, I've got our definition for what an equation is. We've written equations in this class, but a lot of the time we've been looking at something called an expression, not an equation. Equations are going to be statements that say 2 amounts are equal. So when you write an equation, like 2 plus 2 equals 4, you are saying that 2 plus 2, that amount is the same thing as 4. You're saying they're equal. And the reason I say not everything we've seen in this class has been an equation is because equations have to have an equal sign in them. They have to have this. A lot of the stuff we've been looking at isn't actually an equation, it's an expression. An expression is something like 2 plus 2. That's an expression and not an equation because I'm not telling you what it equals. A lot of the problems we were doing, especially the ones we were doing yesterday, are expressions like this where I'm asking you what does it equal instead of telling you what it equals. So that's the difference between expression and equation. The focus today is going to be on equations and solving equations. To give you an idea of what I mean by solving an equation, I've got this right here. I'm saying it's a puzzle, and the puzzle is to figure out what number goes in this box. So this one right here is saying what number plus 4 equals 9? What is that missing number there? That number would be 5. 5 plus 4 equals 9. What about this next one? 7 plus what equals 8? Well, 7 plus 1 equals 8. This next one, 21 equals 9 plus what? This is usually the toughest one for students. What should that number in that box be? It might take some guess and check, but that missing number there is 12. 9 plus 12 equals 21. Now I've got 3 more over here that we're going to do, and then we're going to talk about anything we see. These last 3 here, these are all subtraction problems. This first one says, what number minus 1 equals 4? You might be tempted to say 3 at first, but 3 minus 1 doesn't give you 4. 3 minus 1 is 2. That missing number is 5. 5 minus 1 is 4. What about this next one? What number minus 3 equals 9? That missing number, it's not 6. It is 12. 12 minus 3 equals 9. And then the last one, 8 equals what minus 12? Again, this is usually the one that takes students the longest. Maybe a little guess and check. That missing number is 20. So now for these, it's harder because you're not in the classroom with me, so I can't ask you how are you figuring these out. Sometimes in the past, students have said, well, I was just, guess and check. I was thinking, is this number 2? No. 3? No. 4? No. And guessing some numbers until they found their correct one. But there's actually a strategy you could use. Let's just focus on these first 3. What could we do each time to find this missing number? Well, each time I notice that if I look at the 2 numbers we can see, if I were to subtract those 2 numbers, it would give me this missing number. Again, if I look at these 2 numbers I do see, if I were to subtract those, I could find this missing one. Subtract these, find this missing one. So even though every single time this was an addition problem, because I'm missing something in the middle, I could use subtraction. I'm just going to write subtract. I could subtract to figure out those missing numbers. Now what about these over here? All of these were subtraction problems. What could we have done to figure out that missing number? Well, it's similar. It's like the opposite of this. Even though these are all subtraction problems, if I look at the 2 numbers I do see, I could add those together to figure out my missing number. I could add these together to find that missing number. Add these together to find that missing number. We could use addition. We could add. The reason for this is because addition and subtraction are opposites. So if I'm giving you something like 4 plus, I said 4 and I wrote a 5. 5 plus 4 equals what? Well, that is just a straight addition problem. We can add those and say 9. But these problems where you might be missing part of the addition problem, like this, you could do the opposite and subtract these to find that missing number. Now we said today's lesson is focusing on solving equations. What I was doing here is solving equations. I'm trying to find that missing number. That's what we mean by solve equations. The difference is it's not going to look like this. It's not going to say what number goes in that box. Instead of using a box, when we are talking about solving equations, you use something called a variable. Instead of having to draw boxes on our paper all the time, instead you use a variable, which is just going to be a letter. So if at any point in your life you have seen letters in math, we have arrived. This is the day where we start including letters in our math problems. So a variable is going to be a letter, and we use that letter to represent an unknown number. So instead of those last problems where I said, what number plus 2 equals 5? Instead of drawing a box there, I could say that same thing by using a variable. I could use a letter like x and say x plus 2 equals 5. The idea is the same. Instead of saying what number goes in the box, I would say what number is x. And instead of answering by putting 3 in the box, you would answer this by saying x equals 3. So what we're doing today is going to look like this, not this. Now, those last ones I tried to make a little easier. They were all whole numbers. I didn't give you any decimals or fractions. They also were all positive numbers. But sometimes when you go to solve equations, it's not as easy to see what the answer is. So if everything's nice, positive, whole numbers, small numbers, it might be easier for you to look at this and know what the answer is. But sometimes when you've got negatives, you've got larger numbers, you have decimals or fractions, it's not as easy to just look and be like, oh, I know that answer. So what I really want to emphasize today is a process we use to solve equations. There's a way to put some work down to show your thinking and to show why your answer is the answer. Now this process is really important. This work we're going to do is really important because you might just be a whiz at math and you might be able to look at all of these and know what the answer is without doing any work. But remember, I said equations are really a big focus of pre-algebra. We're going to start looking at crazy looking equations that even I cannot look at and know the answer immediately. So I really want to emphasize learning the steps we're going to do today. So what these steps say is right now I've got 4 plus x equals 10. Remember, we're trying to figure out what number x is, and you might already know that. And that's okay. That's great that you already know what it is. But my goal by the end of this is to say that x equals a number. That's saying that missing number x equals something. So I want it to look like this. So what part of our work is going to look like is I'm going to draw a line here to show the two sides of my equation. And I want to get x, my variable, all by itself. Which means I don't want it to say 4 plus x. I just want it to say x. Which means I need to get rid of 4. Now the way we do that is by doing the opposite. So right now this says plus 4. I'm going to do the opposite. And the opposite of plus 4 is minus 4. I'm going to write minus 4 right here. The reason that helps me is because what am I going to have over here? Well, 4 minus 4, that gives me 0. 0 is nothing. The word we use in math a lot is it cancels out. Means there is no more 4 in my problem, and all I have left is x. Now, an important thing when it comes to solving equations is whatever you do on one side, you have to do on the other side. So see how I wrote minus 4 here? I also have to write minus 4 here to keep the sides equal. It's an equation, right? So whatever you do on one side, you got to do on the other side to keep it equal. So over here I wrote minus 4, and I said 4 minus 4 is 0, so it cancels. On this side says 10 minus 4. What is 10 minus 4? 6. So we figure out that that missing number that goes right here is the number 6. My answer is x equals 6. Now, when it comes to writing your work, depending on where and when you learned this, your work might be a little different. Not everyone draws a line there. If it helps you, I encourage you to draw it. If it doesn't help you, don't worry about it. Sometimes instead of writing the minus 4 here, people will write it after the 10. If you like doing that, go for it. The idea is the same though. Everyone should be doing 10 minus 4 to get their answer. I'm going to do these next two, and then I'm going to talk about how you can check all of these. This next one here, I'm going to do the same way. I'm going to start off by drawing a line at my equal sign. That helps me know that if I do something on one side of the line, I've got to do it on the other as well. And remember what our goal is. Our goal is to get that variable by itself. So in this problem, I'm going to find my variable and check to see what number is with my variable. In this problem here, my variable is y. And so the number with y, the number on the same side as y, is that minus 3 there. That minus 3 is what I want to get rid of. That minus 3 is what I want to cancel. Now, how am I going to get rid of that minus 3? Well, I got to do the opposite. And the opposite of minus 3 is plus 3. So I'm going to put that there. Now remember, whatever I do on one side, I got to do on the other. So I also need to write plus 3 on this side. The last part of this is let's see what's left over when we do that. If I start over here on this side, doesn't matter which side you start with, but if I start here, I've got a negative 3 plus 3. What is negative 3 plus 3? 0. So just like before, that is going to cancel out and leave me just with y. On the other side of my equation, I've got negative 2 plus 3. What is negative 2 plus 3? Well, they're different signs, so I'm subtracting. Keep the sign of the larger number, so I get a positive 1. Negative 2 plus 3 is the same thing as 3 minus 2. 3 minus 2 is 1. So my final answer, I got to put an equal sign there, is 1 equals y. Sometimes people like the variable first. You can write this. This is totally fine. Or if you prefer, you can say y equals 1. What that's saying is that missing number right there is the number 1. We've got one last one. Go ahead and tell me what you think we need to do to solve this equation. Not the answer, just what you think we need to do. Well, in order to solve this equation, again, I want to find my variable and find the number with the variable. So in order to solve this equation, I need to get rid of that negative 51. Now, I need to do the opposite. It's tempting to see that plus sign there, but I really want to focus in on what's the opposite of a negative 51. The opposite would be positive 51. I am using a positive 51 because remember, each time I want this to give me a 0. I need it to give me a 0 to cancel out, to get rid of it. So a positive 51 and a negative 51, that's going to equal 0. That's why we're using a positive 51. You want to be careful that you're looking at the sign of the number, not this sign here. That's the sign with z. The sign of 51 is negative, which is why we're using positive. Now when I do that, this right here gives me 0. So I'm left with z equals, and then over here on this right side, negative 15 plus 51, what is that? Well, they're different signs, so I want to subtract them. If I need to subtract on my paper, remember you want to put the larger number on top, and then 15 below. When I go to subtract, I'm going to borrow, and it's going to give me 36. I want to check to make sure I'm keeping the sign of the larger number. My larger number is positive, so my answer here is positive. I get z equals 36. Now the second part to each of these problems is you can check. There is a way to help confirm that you have found the correct answer. Do you have an idea how you would check each of these? Well, it goes back to what this actually means, this answer. When I say x equals 6, remember that means we have found this missing number here. We have figured out that this number here is the number 6. So you can check by confirming. If I put 6 here for that missing number, you can confirm to make sure it gives you something that's true. So if my equation says 4 plus x equals 10, I can check my answer by taking my answer 6 and replacing x with 6. So all I'm going to do is change x to 6 and keep everything else the same. So that 4 plus is still going to be there. It's still going to say equals 10. And all I want to do is check to make sure when I put my answer for x, it gives me something that's true. So I'm going to check and see, well, is 4 plus 6 equal to 10? Why, yes. Yes, it is. That means I have found that correct missing number. There's only one number you can replace x with, so that this equals 10, and that one number is 6. What we just did there is something called substitution. Substitution makes me think of the word substitute, like substitute teacher. A substitute teacher is someone who's coming in and replacing me if I'm not here. It's that same idea of replacing. Substitution is when you replace your variable with a number. So we can check our answers to these by using substitution. If I wanted to check this one here, I'm going to do the same thing. I'm going to start off by copying my equation. I'm going to write negative 2 equals y minus 3. And then to check, I'm going to take my answer, which is y equals 1. I'm going to find y and replace it with a 1. So the y becomes a 1. Whoop, not with that marker. The y becomes a 1. And then everything else stays the same. So I'm still copying down that negative 2 equals, I now have 1 minus 3. And then the last part is that true? What is 1 minus 3? Is it negative 2? Well, 1 minus 3, they're different signs, so I'm subtracting. The larger number is negative, so my answer is negative. So yeah, 1 minus 3, that is negative 2. You could also think about it with money. My bank account says $1, but I try to take out 3. It's moving me into the negatives. It would be negative 2. There's one last one. Tell me what it would look like if you check that last equation. Well, to check this equation, I'm going to copy the original equation down, which is negative 51 plus z equals negative 15. I'm going to substitute. So I'm going to change z to 36 and then just copy everything else down. And then I'm going to do the math to make sure it's true. So I'm going to ask myself, what is negative 51 plus 36? Well, they're different signs, so I would want to subtract. I would want to do 51 minus 36. To do that, I would need to borrow. 11 minus 6, 5. 4 minus 1. 4 minus 3 is 1. So I get 15, keeping the sign of the larger number, so it would be a negative 15, which is what it says. So I see, yes, that's true. I like these because I like anything where I can check my answer, where I can leave confident knowing that I've done it correctly. And I like making sure students know how to do this so you can have that same feeling. If you're not sure if you found the right answer, this is how you could confirm if it's right or not. If I went to substitute and it said something like 4 plus 3 equals 10 instead of 4 plus 6 equals 10. Well, when I look at that and check the math, 4 plus 3, well, that's not 10. That's wrong. That would tell me that I didn't find the correct number. And so that would let me know, well, hey, I need to go back and see, did I do the wrong step? Did I make a silly mistake? Why am I getting something here that's not true? Now that we've gone through over 3 examples, how you solve them, how you check them, I've got these 3 here for you to try. Erase all this. That first equation says 5 plus a equals 12. Go ahead and solve that equation. The second one says negative 4 equals b minus 2. Go ahead and try that. And then that last one says negative 63 plus c equals negative 11. Go ahead and try that. All right. It's usually the second and the third one that students have a little more trouble on in class. Here I want to emphasize, in order to solve for b, negative 2 is the number you need to cancel. I need to go in and add 2 to both sides, which would give me b equals negative 4 plus 2, which is negative 2. Here, I want to emphasize that because that 63 is negative, we have to do the opposite. We want to do the opposite of a negative 63, which is positive 63. That would give you the 0 you need to cancel them, and just say c equals 52. And then, of course, you want to make sure you're checking these as well, especially if it's been a while since you've solved equations or if you've never seen this before. Now notice all of these equations here had something in common. They all were addition or subtraction problems. The second part of this lesson is what to do with multiplication and division ones. So similar to what we started off with, I've got this idea again of what number goes in the box. Go ahead and tell me what these 3 missing numbers here are. For this first one, it would be 8 times 4 equals 32. This next one, 7 times 7 equals 49. And then this last one, 3 times 3 equals 9. What about these last 3 here? What number goes in those boxes? This one here, 12 divided by 3 equals 4. This next one, 42 divided by 7 equals 6. This one here, people are always tempted to say 2 because they're thinking 12 divided by 6, but that's not what it's saying. It's saying what number divided by 6 gives you 12. That one might make you think a little bit, but that number is 72. 72 divided by 6 gives you 12. So similar to the first part of this lesson, I've got the question, what could we do? Instead of just playing this guess and check game, what could I have done each time here to find that missing number? Well, similar to before, even though they're all multiplication problems, I could do the opposite. I could divide. I could look at the numbers I do see, divide 32 by 4, and it would give me 8. 49 divided by 7 gives me 7. 9 divided by 3 gives me 3. So we could use division. We could divide to find those missing numbers. Similar over here, what could we do? Well, I could multiply. Even though these are all division problems, I could do the opposite. I could multiply the 2 numbers I see to find that missing number. 3 times 4 gives me 12. 7 times 6 gives me 42. 6 times 12 gives me 72. So what could we do to find those missing numbers? We could multiply. Just like adding and subtracting are opposites, multiplying and dividing are opposites. And we can use that fact to help us find these missing numbers. Now, just like in the first part, it's not going to be this game of what number goes in the box. Instead, our equations are going to have variables in them. It's going to have those letters again. So when we're looking at equations to solve, ours are going to look something like this. Now, this right here is something we have not seen before. I've got a number right next to my variable. Remember, variables are numbers. So I want you to think back to where we've seen a number right next to a number before. Nothing in between, no signs, nothing. We've seen that before with the parentheses. Something like, I'm going to make up a number. Something like this. before. When there's no sign between two numbers, I meant multiplication. The idea here is the same. If I've got negative 4x, that means negative 4 times x. If that's something you don't already know, I would definitely make a note in your notes that right there means multiply. It means negative 4 times x. Now that's important to know because remember when we're solving, we're always doing the opposite. So I need to know that this means multiplication because if I know it means multiplication, then I know what I need to do. The opposite of multiplication is division. So in here, I would want to divide on both sides of my equation. Now you could use that typical division sign if you want to, but the most common way you're gonna see this is using that fraction line. So I'm gonna come in and say, I want to divide on both sides. What number do I wanna divide by? Well, I wanna get x all by itself, and the number right now with x is negative 4. Right now we're doing negative 4 times x. The opposite of multiplying by negative 4 is dividing by negative 4. So I'm gonna come in and divide both sides by negative 4. Now I wanna emphasize something here. I am dividing by a negative. This is a negative 4 and I'm dividing by a negative 4. Earlier when we were talking about addition and subtraction, the opposite of addition is subtraction, opposite of subtraction is addition, so we had opposite signs there. But here, both of these are negatives. That's gonna be important because I wanna see what I get when I do that. If I do negative 4 divided by negative 4, what is negative 4 divided by negative 4? 1, positive 1. So I'm left with a positive. I don't want a negative sign here. I need two negatives here so that when I divide, I'm left with positive x. And there's one x there. On this side here, after I cancel those negative 4s, I've got 12 divided by negative 4. What is 12 divided by negative 4? Well, 12 divided by 4 is 3. And then the positive divided by the negative gives you negative. So we're left with x equals negative 3. If I wanted to check that, we could do the same thing before. What is it called? What I'm about to do in order to check? Substitute. I'm going to check by substituting. I'm going to take my equation, negative 4x equals 12, and I'm going to substitute x equals 3. And not x equals 3, I'm going to substitute x equals negative 3 into that equation. So when I write it, remember this is multiplication. So to show that it's multiplication, I'm going to choose to use parentheses there. You could use the little multiplication x if you want. You could use the multiplication dot if you want. Notice I'm using parentheses because now that we've actually got the letter x in the problem, that multiplication x looks a lot like the letter x. So that's why we've got these other ways you can show multiplication. When I substitute x as negative 3, it says negative 4 times negative 3 equals 12. Well, what is negative 4 times negative 3? Well, 4 times 3 is 12, and negative times negative is positive. So that tells me my line here is all good. It's correct, which tells me I found the correct missing number. Now this right here says 2 equals y divided by 4. We haven't seen one that looks like this yet. What do you think I'm going to need to do there? Well, in this one, this time our variable y is being divided by 4. Remember, this right here means division. So just like earlier, I want to do the opposite. The opposite of dividing by 4 is multiplying by 4. So I want to come in and multiply both sides by 4. I'm going to actually write, instead of putting it under, I'm going to put it up here this time. I'm going to show I'm multiplying both sides by 4. And I'm doing that so that it's really clear that over here it says 4 divided by